Hi everyone, we are continuing the factorials where we left in last video. So in last video, we're trying to figure out how do we calculate the highest power, and we learned some basics about it. So we'll be continuing from there. So let's say if we are asked what is the highest power of 12 in 80 factorial. Okay, so as I've said before, doing this would be a gross mistake. If we do this and we say 12 to the power 6, this would be gross mistake. The simple reason is that because we have to break it into form of prime first, so this would be a wrong method to do. Okay, now in last video I said that whenever we break into the prime video, we should look for the highest factor because that would generally have low index or low power. But over here, don't do that thing because the if you see over here, this is basically 4 and it's written in 2 square format, so we have to calculate for both of them. Okay, so first we'll calculate for 2 because we need to see which of these number would carry a small number power. Basically it would be this because it is generally a higher number, but still we need to calculate first. Okay, don't go blind on this. 10, you have 5 2 1, so yes, so 40 20 60 70 75 78. So if we have 2 to the power 78, it would be 2 to the power 39, and if we take 80, it is 80, so this is 26 8 2, so this is 36. So as expected before, so 36 would be the highest power because again this has 39 pair and this has 36 pairs, so a total of 2 square into 3, we can only have 36 such pairs. This is what we have studied before, so 36 would be the answer. So otherwise, if you would have done the other method as well, so if we are doing the method wherein I said that we should look for the larger factor, so we will consider this, not this. Okay, because this is still 4, we have just broken into this format. Okay, okay, wonderful. Let's do another question. Okay, what is the highest power of 18 that divides 108? Let's say, okay, could be any number. What is 18? 18 is 3, 2 into 3 square. This is what we have, 18. So again, so we'll start with 308, so 36 12 4 1, so 36 12 48 53, 3 to the power 53 we have. So we can write 3's values. So if we have to write in this term, so we can write is 3 to the power 52 into 3 to the power 1, or 3 squared to the power 26 into 3. So this is not relevant for me because this is with the highest power, and if we want to calculate for 2, of course with 2 we would have higher number, so this would be the answer because with 2 or 2 na, so we have 54 27 13 6 3 and then 1. So of course if we add, it's going to be more than 26, so the highest power would be 26. Okay, now one more question. What is the highest in 60 factorial? And then we have, what is the highest power of 10 in 60 factorial? Okay, so again, highest power of 5, what do we do? 60 12 2, so we have 14 again 10. How do we write? 2 into 5. We need not to calculate for 2 because 2 would have generally number of 2's would exist more than the 5. So again 5 to C. Now if you observe it very carefully, so you will find that the power of 10 and the highest power of 5 are similar. Okay, it's 14. So what does it mean? It means that 60 factorial, let's say 60 factorial is 1 2 3 4 5 6 7 8 9, and beyond that, beyond this there would be 14 zeros. Okay, so any when we calculate 60 factorial, so it would have any set of numbers, and those numbers would be followed by these number of zeros, 14 zeros. So what happens? See, let's say we say how many zeros do we have in 10? Okay, so you say 1 0. Why? Because it's 10 into 1. So for 100, if we say it means 10 into 10, it means you have 2 tens. For 1000, it is 3 10. That's how you break it. Okay, so the number of 10 shows us that how many zeros would be there in a given factorial. Okay, so how do we determine how many tens you have? So we can calculate the highest number of 5, because we have just seen the highest that the power of 5, highest power of 5 is equal to highest power of 10. Equal to trailing zeros, and as many as 5 we would have, as many as trailing zeros we would have. Okay, so this brings us with the concept of trailing zeros. So let's say we have a question for that find the number of trailing zeros in, you can pick any 100 factorial. Okay, so what are we going to do? We are just going to simple. So you have 24 trailing zeros in 100 factorial. That's very, very easy. Okay, now if you have another question, find, let's say, okay, find the, you can calculate anything of this number of trailing zeros in, let's say, you can pick any number, even those number which does not have 5 in it. You can say 29 factorial. Okay, generally 29 is not a factor of 5, still you can calculate. So you have 4 zeros, no, I'm sorry, you have 5 zeros. Okay, 5 zeros, 25, and then 6. So you have 6 trailing zeros in 29 factorial. Okay, now coming back to the highest power thing, we can do a couple of more questions. Okay, find the highest power of 14 in 30 factorial. Come on, try doing this. Okay, I'll just pause it for a moment and you do it. It should be done in 5 seconds, not more than that. It's very simple, it's not that difficult. 14 is what? 2 into 7. Don't calculate for 2, just calculate for 7 in 30. 7 4 20, so it will be 4. Simple. Again, find the highest power of 11 in factorial by 500. Let's make it 500 factorial. Okay, so how would you do this? Very simple. Again, first find, so how much it would be? 11 9 1, and then you have 8 9 0 and 9 8 9, and then you have 8. So you have 98 and then 11 in 500, how much you have? In 4 and 6 you have, and then 11 5 and then how much we have? Then we have 4, so this is 49. So can we write this in 1198 by 11 to the 49? Now it can be done from here, isn't it? If we know a to the power m, a to the power it's am minus n. So what would be left? We will be left with 1149. Simple. We're just trying to do some questions for the highest power so that you understand how this has happened. Okay, look over here. Not that difficult. Okay. Now again, you find the number of trailing zeros in 60 factorial, if we say. So how can we do this? 5, 60, 12, 2, we have 14, isn't it? Okay, so this is very easy concept. Now we'll jump from this concept to yet another concept. Okay, so again, let's do it through a question. So find the number of trailing zeros in 49 factorial, 50 factorial, 54 factorial, 55 factorial, and then take it 59 factorial and 60 factorial. Okay, so this purpose that I've given, these are 3 sets, rather you can consider there's some purpose behind it that I've given these numbers. So how much do we have? So 10, and then in 50 if you want to see, 12. In 54 I would say 12. In 55 you have 13 trailing zeros. In 59 you have and in 60 you have 14. Now see one thing, okay, just observe it for a second, okay, before you reach a conclusion. In 49 factorial you have 10 zeros, and in 50 you have 12 zeros. You have 12 zeros in 54 factorial as well. Look over here, 50 factorial you have 12 zeros, and you have 54 factorial you have 12 zeros. Even in 51, 52, 53 you would have 12 trailing zeros. Now again, but in 55 we see there's an additional, and from 55, 56, 57, 58 and till up to 59 you have 13 zeros. Okay, now this again changes. Now this is good for all these numbers, but what is good, what's happening over here, we need to find that. Okay, so let's write this observation in a form of generalized pattern. So if we want to know about trailing zeros over here, so can we say like this? Okay, let's say from 1 factorial to 4 factorial, how many trailing zeros we would have? We would have 0 trailing zeros. You can see 4 factorial is 24, 3 factorial is 6, 2 factorial is 4. So we need at least 1 5 to have a 0. That's what we have studied before. So we have 5 factorial to 9 factorial, we have 1 trailing zeros because we have 1 5 over here. From 10 factorial to 14 factorial, again we have 2 trailing zeros. From 15 factorial to 19 factorial you have 3 trailing zeros. from 20 factorial to 24 factorial, you have 4 trailing zeros. Now how are we following this? So what should be there here? 25 to 29 factorial, how much should we have? It would have 6 trailing zeros. Now this is a breaking point. Okay, this is the breaking point for the concept. How many zeros it should have? It should have 5, but how many it is? It is having 6. We can calculate 1 6 for 26 again. So up to 29 you can calculate, you would have 6 trailing zeros. But how many it should have? It should have 5, but it has 6. Okay, so what we have done, what has happened? We have skipped the format. In fact, not we, but the format had skipped 1 0. Okay, now again, if we go from this 30 to 34, it would have 7. From 35 to 39, it would go 8. You can calculate it. It's not anything random. Okay, so 35 to 39. So you have 7 plus 1, 8. This would go on. Now, again, now let's see. 124 factorial, how many zeros would be there? So let's calculate. 124 is 24 and 4. So you have 28. And 125 factorial would have 25, 5, 1. So 31. So going by this pattern, let's say we reach over here 124 factorial. So 124 factorial has 28 trailing zeros, whereas 125 factorial has 31 trailing zeros. So what has happened over here? We have skipped some 3 zeros. Again, if you go by the same pattern, we reach 624. Okay, we reach 624. So in 624, how many zeros do we have? So 124, 24, 4, these many, I believe. 124, then 20 and 4. Yeah. Okay, so how many we have? So we have 152, I believe. 152 trailing zeros. And if we calculate in 625, I'm just calculating over here 625. So it's 125, 25, 5, and 1. So how many we have? We have 156, I believe. 156. 625. We have 156 trailing zeros. Okay, I'll just start over here again. In 624, we have. In 624, if we calculate it, so we have 124, you have 24, and you have 4. So how many zeros we have? 2, 152. And in 625, you have 5. So 125, 25, 5, and 1. So 156. So how many zeros we have skipped? We have skipped some 4 zeros over here. So what is happening over here? When we were in 25 factorial, so we skipped 1 0. When we are in 125 factorial, we have skipped because 124 factorial had 28. In last clip you would have seen. So we have skipped 2 trailing zero. We have skipped 2 zeros. In 6 excuse me, in 625 factorial, we have skipped 3 trailing zeros. So what's happening over here? Just see, up till 24 factorial, there was just 1 5, but in 25 factorial there is another 5 that has come to the place. Similarly, in 125 we have 5 into 5 into 5. We have 2 extra 5, therefore 2 trailing zeros. 5 into 5 into 5 into 5, 3 extra 5, so 3 trailing zeros. So let's say there would be a number, any number, which is 625 into 5. So how many zeros it would skip? It would skip 4 zeros. It would skip. Okay, over here we have skipped 1 0 over here, 2 zeros, and over here 3. So as the number of 5 would keep adding up, okay, so the 0 would be missing. It would be missing these zeros. Okay, now this is a very beautiful concept. Okay, very beautiful concept. So what we have seen that no factorial would have 5 trailing zeros? Of all the numbers in this entire world universe, there would be no such factorial that would have 5 trailing zeros. Why? Because 24 factorial has 4 trailing zeros and 25 factorial has 6 trailing zeros. So you see, there's no factorial that exists with 5 trailing zeros. Similarly, no factorial would have 29 and 30 trailing zeros as well. Why? Because 124 factorial is what? 28 trailing zeros, and 125 is what? 31 trailing zeros. Yeah, so 29 and 30, you don't have any trailing zeros. Similarly, no factorial would have how many zero? 152, so it will be 153, 154 and 155 trailing zeros. Simple reason, 624, you have 152 and 625 factorial. All these are factorial, okay? So you have how many? 156 trailing zeros. So very simple. Understand this concept. So this is the concept of skipping zeros, okay? Now let's do some questions, okay? Understand it, and we'll do a question. Let's say, what would be the minimum value of k for which no factorial would have k plus 1, k plus 2 trailing zeros, okay? Now see, this is a general rule. Even when you go for appearing in CAT examination and any other such standard examinations, don't read at the questions, especially in CAT, because questions, these are just blatantly word to make sure that you are surprised by looking at the question. Always try to see what is behind the question, because half of the answer you would find within the question itself if you don't if you don't get scared just by reading the reading the words in the question, okay? So make sure just read it and interpret it in many other ways you can do it. So over here it has given k plus 1, k plus 2, okay? So what is k plus 1? K plus 1, k plus 2 are what? Consecutive numbers, isn't it? So what is it asking? It's asking what is the minimum value of k for which no factorial has these many zeros. No factorial has these 3 consecutive numbers as their zeros. So what do we know? From previous slides, we have learned that there are no factorials. There are no factorials with 5 trailing zeros. Also, there are no factorial with 29 and 30 trailing zeros. Why? Because 124 and 125, but again it does not satisfy because we need 3 consecutive numbers. So we need 3 consecutive numbers. Understand? Okay, you don't need to remember this thing as well. It's a 3 consecutive zero. What does it mean? It means it is skipping 3 zeros. And as I said, with every skipping zero, it means extra 5 is added. So there's only 1 5. Okay, now it says it's skipping 3 zeros. So it means it is 3 zeros, means there are 3 extra 5s are being added on the place. So what do we have? We have 625 and 624 factorial. Okay, so in 625, how many trailing zeros we have in 6? To 152, and over here is 156. So 153, 154 and 155. Now, so what is the minimum value of k? K is equal to 153. K plus 1, 154. K plus 2, 155. So k is nothing but 152. Just think, this is a very standard question, very tricky question. Most of us would perceive it as a very, very tough question, which It can be if you have not understood the concept. Go through it, and we'll continue this in our next class as well. Okay. Thank you once again. This is Prashant from Competition Value.